Okay, so in this unit so far, we have covered the area of rectangles, parallelograms, and triangles. In the next lesson, we covered the area of trapezoids, rhombuses, and kites. This lesson is going to focus only on circles. So there are several different things we're going to discuss with circles, but the first thing we need to know is what a circle is. So a circle is the set of all points equidistant from a given point called the center. And we name a circle by its center. So like in this picture, this is going to be circle A because A is the center. So in order to do most of the formulas we're going to talk about today, you need to know the difference between a diameter and a radius. So a diameter is going to go from one edge of the circle to the other, and it has to go through the center. So from C all the way down to D would be a radius. All right, so it touches the circle at both ends and it goes through the center. Now a radius only goes halfway across, so that would be from like A to B. So this would be your radius, and then this one would be your diameter. So just as a quick reference there. All right, so the first formula we're going to talk about is the circumference, and this is the distance around the circle or the perimeter of the circle. And you can think about it as 2 times pi times the radius, or pi times the diameter. So the radius is always twice the size of the diameter. So that's kind of a way to look at that aspect of it. And as far as pi goes, I want you to think about pi as the pi button on your calculator, or 3.14159. So this is going to be pi. All right, so example 1 says find the circumference of a helipad that has a diameter of 79 feet. So since this one, and we're going to round this to the tenths place, not the hundredths place. Okay, so since this one gives me the diameter, we're going to use the diameter formula. So we know that circumference equals pi times the diameter. So in this case, it's going to be 79 pi, because the diameter is 79. So 79 pi. And then we're going to take 79 times 3.14159, or times the pi button, and we get 248.2 feet. So again, 79 pi, which is 248.2 feet. Okay, now example 2 says we're going to work backwards. So we want to find the diameter and the radius of a circle with the given circumference. And it says round to the hundredths, but we're going to, again, round to the tenths place because that's what your homework asks you to do. All right, so we're going to work backwards. So we're going to start with the formula. And we know the circumference is 40, so we're going to solve this for D. So the first thing I'm going to do is I'm going to divide both sides by pi. And when I do that, we're going to get the diameter equals 12.7 and some stuff. So I'm not going to clear my calculator. I'm just going to go ahead and just push divide by 2. So we're not clearing the calculator, we're just going to push divide by 2, and we get a radius of 6.4. Okay, so why did we divide by 2? Because the radius is half of the diameter. Okay, so now that we can do circumference, which is all the way around the circle, now we're going to talk about arc length, which is just part of or a fraction of the circumference. So notice that the formula still uses the circumference, right? This is the 2 pi r. But now we need a fraction in front of it, and it's the degrees of the arc or the angle divided by 360. So let's look at example 3, and we want to find the length of the darkened arc. So we want to find the length of this part of the circumference. Well, a circle is 360 degrees, and it tells us that this part is 90. So we want everything but 90. So we're just going to take 360 minus 90, and we get 270. So we want 270 degrees of the circle. So 270 divided by 360 times 2 pi, and then my radius here is 18. So when I put this in the calculator, I'm going to do 270 divided by 360 equals times 2 times 18. So I'm going to deal with everything but the pi first. And I get 27 pi. So again, that's 270 divided by 360 times 2 times 18. And then when I multiply by pi, we're going to get 84.8 meters. And again, we're going to round to the tenths place because that's what the homework asks you to do. So that would be the arc length. Let's try this again. We're going to find the length of DE. So from D to E, we want the length of that part of the circumference, that arc length. So again, we're going to take the degrees, which is 120, divided by 360 times the whole circumference. So that's 2 pi, and then it does tell you your radius is 2. So 220 divided by 360 equals times 2 times 2. You get kind of a weird number, 1.3 repeating pi. So without clearing my calculator, I'm just going to do times pi, and I get 4.2 meters. Again, 4.2 meters. Okay, the next formula we're going to talk about is going to deal with area. So we just talked about circumference, which is basically the perimeter of the circle. We talked about arc length, which is just a fraction of that circumference or a fraction of that perimeter. Now we're going to talk about area. So area, just like all the other shapes, is the stuff inside of it. Like if I wanted to lay down carpet, that would be the area of the room. So for a circle, the area is pi r squared. So that is the formula for area. So I look at example 5. It says find the area. So we know that that is pi radius squared. So the radius here is 9 squared. So 9 times 9 is 81 pi, and then I just take 81 times pi, and we get 254.5 feet squared. Now notice we're back to units squared because we're dealing with area. Now the problem with B is it's giving you all the way across, so this is giving you the diameter, but our formula only uses radius. So the first thing I have to do is I've got to divide this by 2. So our radius, 8.6 divided by 2 is 4.3. So now pi times 4.3 squared is going to give us our area. So 4.3 times 4.3 is 18.49 pi. And then when I take that times pi, we're going to get 50.1 inches squared. Again, it's area, so it's got to be units squared. Okay, so just like we did with circumference, we're going to try one of these backwards. So it says, find the radius of a circle if the area is 95 centimeters squared. So let's think about that formula. Area equals pi r squared. We know the area is 95. So I need to get r by itself, so we're going to get rid of the pi. We're going to divide both sides by pi, and we're going to end up with 30.2 equals r squared. And then just like with Pythagorean theorem, to get r by itself when it's a x squared or an r squared or a c squared, we've got to square root both sides. And the square root of 30.2 is 5.5. Now this time I'm not dealing with area, right? Because the area is 95 centimeters squared. I'm just dealing with a segment, so I don't square this one. It's just 5.5 centimeters. All right, that takes us to the last formula, which is area of a sector. So area of a sector is kind of like arc length, except for we're going to use the area formula this time. So we want a fraction of the area. So area of the sector is just a fraction of the area. So if I look at example 7, we want to know the area of this shaded part here, this part right here. So I'm going to use the degrees, so 72 over 360 times pi r squared, so pi 15 squared. So 72 divided by 360 times 15 times 15 gives me 45 pi, which when I multiply by pi, I get 141.4, and we're still dealing with area, so centimeters squared. The last one's going to work the same way. So again, the degrees, which is 148 over 360 times pi r squared. So 148 divided by 360 times 6 times 6 gives me 14.8 pi. And then we take 14.8 times pi, and we get 46.5 meters squared. So again, arc length is just part of the circumference. So it's a fraction times the 2 pi r. And area of a sector is just part of the area, so just a fraction times pi r squared. So that's pretty much going to cover the worksheet. So the front of the worksheet is the circumference and the area, and the back of the worksheet is the arc length and the sector. So if you have any questions, go ahead and email me or reach out, and I will try to help you. Thanks. Bye-bye.